You are welcome. Let's talk about the concept of addition. Addition, yes. So, what comes to your mind when we talk of addition? Addition, yes. Well, you know it as a mathematical operation. So, but what does it really mean? It means counting together. For example, we may have 1 plus 2. It means we are counting together 1 and 2, which means when we count them together, we have 3. So no matter how big the numbers are, the concept remains the same. It is counting together. Okay, let's look at this using the two pictures below. Explain why 2 plus 3 equals 3 plus 2. Don't forget, addition means counting together. For the first picture here, we can see we have 2 squares above 3 squares. So we need to count the number of squares together. And in that case, we have 5 when you count. Come to the right hand side. We also see we have 3 squares above and 2 squares below. So when you count them together, we have 5 squares. So, but what has really changed? Yes. Do you know what has changed between the two pictures? If you look at the left hand side, this, when you flip it, you arrive at the right hand side. So flipping means you are turning upside down. When you turn this upside down, you have the right hand side figure. So this really tells us that when you flip, you arrive at the same answer. You have been able to flip the numbers 2 plus 3, and we have arrived at 3 plus 2. We arrive at the same result for both. So this tells us that when you flip a shape or a figure, it does not really affect the counting that we have there. So doesn't have, in this case, we have squares. So when you flip the figure, it does not affect the counting of the squares in that figure. So in mathematics, we call that commutativity property. Commutativity property. So it means when you flip figures, it does not affect our result. And that is what you can see there. 2 plus 3 is the same thing as 3 plus 2. All right, thank you. Let's look at additional concepts. So look at this concept using the two pictures below. Explain why 2 plus 3 plus 4 equals 2 plus 3 plus 4. We can see the parentheses there. What does it mean? Parentheses is telling us that we perform the operation in the parentheses first before we move to the other. So here, it means we are adding 2 plus 3 first. Then, for the second one, we are adding 3 plus 4. So look at the picture here. You can see that some squares have been darkened in the first figure here, which is the one on the left hand side, and the second, which is the right hand side. Some other squares have also been darkened. Now, what do you see the difference between the two? Here, it means we want to add the squares of the same color first. So that is what you can see here. The one that have the same color here, there are 2 squares and what? 3 squares. So add them first before you add to the one of different color. So that is what we have done on the left hand side. For the right hand side too, the ones of the same color are 3 and 4. We'll add them first before we add to the one of different color. So how are they different? Can you look at the first picture, the one on the left hand side, and the second one, the one on the right hand side? What is the difference? Oh, yes. The major difference is the color of the middle. Can you see? Color of the middle. The first layer, they have the same color. The last layer, they have the same color. But the only difference here is what? The middle layer color. Now, so that is telling us that the color of an object does not really affect the counting of such objects. So whether we have different color or the same color, we still arrive at the same number here. If you count, 2 plus 3 is 5, plus 4 is 9. So we have 9 squares here. The same thing here. We are counting the one of the same color first. So 3 plus 4 will give us 7, plus 2, which is the one of different color here, and that gives us 9. So it means irrespective of the color, our target here is we are counting together. So our counting remain the same. So what do we call this in mathematics? That is associativity property. What we have only done is we have changed the order in which we have added. Don't forget the first one, commutativity, we flip the figures. The second one here, we are changing the order. We are adding the first two here, and the second one, we are adding the last two. So we have changed the order in which we perform the operation. So the two concepts, commutativity property and associativity property, they bring about what we call any other property. Any other property. So let's see how we can apply any other property. All right. So the next, explain why 472 plus 219 plus 28 equals to 472 plus 28 plus 219. For the first one, you can see the parenthesis is at the last two. Here, the parenthesis is at the first two. But when you look at the two sides, you realize that the second one here is 219. It's different from the second one here. So we cannot directly say it is associativity that will make them to be equal. So, but let's see, can we combine commutativity with associativity? Don't forget, commutativity is when you flip. Now, let's start from the left hand side here. If we flip the one in the parentheses, always remember we start with the parentheses. So let's flip these two numbers. If you flip, we have 472 plus 228 plus 219. So we have been able to flip. And according to our commutativity rule, flipping does not change the result of our counting. So we have it like this. Then can we also what? Reorder it. The last two have been added here. Can we change it that we had the first two? All right. So if we do that, we have 472 plus 28 first. Then we had 219 to it. Yes, we are there already. You can see it is the same as what we have here. So it means we have been able to explain why the left hand side here is equal to the right hand side here. What do they do again? We have flipped the last two, the one in the parentheses here, we flipped. So when we flip this, we arrive at this. And the next thing is what? We reorder it. We reorder it. So we have used the principle of any other property. Okay, so the next one is compute 472 plus 219 plus 28. You realize that this is exactly what you have on the left hand side here. But we have seen that it is equal to the right hand side. Yes. Why do we want to compute using the right hand side and not left hand side? Now, you can see that 219 plus 28, if you need to compute it, it may look tedious. You cannot easily compute it, except you now write, okay, 9 plus 8, 2 plus 1, and no, we don't want that. We have a concept called pair of 10. Yes, pair of 10. So let me write figures or numbers from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we realize that some numbers, two pairs, will give us what? 10. So that is the target. Two pairs that can always give us 10 to make our addition very easy and seamless without using calculator. All right, 0 plus 10 is 10. So 0 and 10 are pair that will give us what? 10. 1 plus 9 will give us what? 10. So 1 and 9 are pairs of 10. 2 plus 8 will also give us 10. So 2 and 8, anytime you see them, they add up to give us 10. The same thing to 3 and 7, 4 and 6, 5 and 5. So that is our target. So based on that, we can simply say that 472 plus 219 can be equated to the right hand side here. 472 plus 28 plus 219. Now you can see that 2 and 8, they are pair of 10. So they add up to give us 10. Is that clear? So meaning that you can easily add these two numbers together. 472 plus 28. If you add this 8 to this 2, we have 480. 480 plus 20. You can see also 2 and 8. It will give us 500. So we have 500 plus 219. And we can easily say it is 719. So you can see it made our addition easier and seamless. So when you change, when you flip or reorder numbers, our addition. All right. So yes, we can use this to do so many things. Look at this. Compute. This. Yes. Remember, we have 2, 2, 2, 2, 2, and 8. So pairs of 2 and 8. We can use any other principle here. Any other principle means you can add them in any order. So I can take pairs of 2 and 8. In this case, I also need to look at how do I add it to make it easier for me. So in that case, you can see this is in ascending order. This is also in ascending order. Can I pick the last one here and the first one here? Let's see. 32 plus 8. Will it give me something elegant? Yes. 22 plus 18. 12 plus 28. And 2 plus 38. I don't want to add such that I will add the first one to the first one here. 2 plus 8, it will give me 10. 12 plus 18, it will give me 30. So I'm having different number. But I want to add such that I have the same number. So if you take the pairs, we have 2 plus 38 plus 12 plus 28 plus 22 plus 18 plus 32 plus 8. Okay, so this gives us 40 plus 40 plus 40 plus 40. So how many 40 do we have? We have 4 of 40. 4 times 40. And we can easily add it as 160. You can see that the addition is easy for us. So we have so many. This concept, we can also use it to add numbers from 1 to maybe 50. or for example to 10. Let's start from the easier one. So how do you use it to add this one easily? Yes, yeah, we can also add from 1 to, in fact, 2,000, 30,000 easily, without any stress, without using calculator. But if you need to get that, it means you need to join us at our summer coaching class. The detail will be seen here. So this is it. Join us to get more and get uh, practicing with what we have taught you. Yes, we have app where you can practice. It's just for 5,000 naira. And so I will be expecting you in our class. Thank you.